Okay. Okay. Okay, now we start to the introductory linear algebra. Okay. Linear algebra is one of the most important branch of mathematics for the college student, which is central to both pure and applied mathematics. And in this chapter, we begin with studying basic properties of vectors, starting from three-dimensional vectors and extending these properties to n-dimensional vectors. Okay. We also introduce the notion of the dot product and inner product of vectors and the vector equations of lines and planes. You will learn a new, easy way of explaining the equation of lines and planes by using the new concept, which is an inner product. Okay. You can see those explanations in this web address. Okay, I gave you the introduction and some orientation regarding to this course, and I add some more information on what you're going to learn through this introductory linear algebra class. Okay, you will learn vectors and vector spaces and linear maps and the system of linear equations in this chapter. And the concept of vector space is a central theme in modern mathematics. And linear algebra is widely used in both abstract algebra and functional analysis. Also, linear algebra has a concrete representation in analytic geometry, and it is generalized in operator theory. It has extensive applications in the natural sciences and the social science, since non-linear models can often be approximated by linear ones. So knowledge of linear algebra is also a central part of numerical and computational mathematics, including the machine learning and big data. One of the applications of linear algebra is the solution of simultaneous linear equations. The simplest case is when the number of unknowns is equal to the number of equations. Okay, so it's which you have learned. And I introduced you the textbook. Then I wrote this book before, several years ago, and I made the free ebook in Korean version for students. And also, recently I finished to write the English version of this linear algebra ebook for free, which you can download from this web address. We will use this English version of linear algebra ebook for this class that you can download from the web address. This is ISBN number of it, and you can also get the printed version of the book from print on demand from the Kyobo Books. And this free book was possible from the generous support from the Hyundai Car Foundation. Okay, we will cover from chapter 1 to chapter 10, from vectors to the Jordan canonical forms. And the evaluation will be based on, as you see in the syllabus, then your attendance, 출석, will be counted as 10%, and your homework and Q&A discussions will be counted as 20%, and your presentation will be counted as 10%. Your quiz and other contributions will be counted as 10%. And midterm examination will be counted as 20%, and final comprehensive examination from the first chapter to the end will be counted as 30%. This is exactly same as in the syllabus that you find. Before we start, I may introduce you some of the mathematical symbols that you will see in the book. And this notation means the implication. And so this means A implies B. So A means B. This is what this notation means. The arrow, just arrow means converts. A converts to X. So this is a double arrow, which is not same as the single arrow. This is the implication. A means B. If A is true, then B is true. This is the notation. And this is the double direct. It has a double direction, which means A means B, B means A, which means they are equivalent. If and only if statement. If A is true, then B is true. If B is true, then A is true. This is what this means. Yeah, you know this. Yeah, X is in capital A. It means X, little a is A is in a set capital A, something like that. Mm-hmm. Subset, you know this notation. And this is therefore can be written in this way, and because can be written in these notations. And maybe these can be new for you. And this notation is used as an existential quantification, which says this. There exists X such that Px, this means there is at least one X such that Px is true. There exists X that satisfies this. This is what this means. So this is a flip of E, capital E, which represents for the existence, exist. And this is for like this, for all X. For all X, P of X is true. So this means P of X is true for all X. So this A is the flip of the capital A, which means the arbitrarily chosen, or all. So for all, there exists. This is a kind of notation that you will see in the book. This kind of notation, which is not many, will make every logical statement of yours in linear algebra is much clearer to be understood by each other. So this is very important that you should know. And orientation, in this linear algebra class, we will learn linear algebra, and we will also use the computer algebra system, which is called SageMath, based on the Python language. In chapter 1, there are 3 sections. Vectors in n space. This is what you already have known. And inner product and orthogonality. And these are the things that covered in high school years for 2 or 3-dimensional vectors. And now we expand it to n-dimensional vectors. And then the section 3, 1.3, vector equations of line and equation. This can be, this may be new to you, most of you, and you will learn how the lines and planes can be represented easily by the concept of vector using the inner product. Okay, for SageMath, for the tool, you can make your own account in here, or you can just use it in here as well. For example, if you go there are many solutions for the problems. And linear algebra section 1.1, exercise from 8 by Mr. Zhou. Here you will see. This is the kind of subtraction of between 2 vectors. So you can easily use others. And you can copy this to practice. You can change this code for the problems that you will find in at the end of each chapter. You can also expand it not only 3-dimensional vectors, you can also use it for the 4-dimensional vectors like this. Understand? You can deal with the same thing for the n-dimensional or 100 by 100, 1 by 100 dimensional vectors. There are there are hundreds of exercises that my students already have done that you will see. This includes some linear algebra and calculus and engineering math and also mathematical modeling. But you will see. Gram-Schmidt orthonormalization process can be done like this, and find for the given vectors. If you have 3 vectors, you can easily find the Gram-Schmidt orthonormalization process like this. And by hand and things. So those are the kind of tips that you can use. So you will not have any difficulty to use the given code that we already have made. And also in this web address, you can do practice like what you did before. This is called the single cell server. Then you can change it, and you can do the computation in many. There are hundreds and thousands of these servers in the world nowadays. And MIT is also using this, and Iowa State University is also using these tools instead of Mathematica or Maple. And this is there are some information that you can on those CAS tool, and these are the outlook that you're going to see in this. Also, you can have your own ID and password. I will make one account here, so you can use it. So you can use it in here. In this web address, ID with matrix, and if you use a password this, then you will be able to use to make changes in there too. I expect one of you, Mr. 강산?
네.
강산군, 이 주소에 들어가서 아이디 패스워드 이렇게 치고 들어가면은 들어갈 수 있어요. 이 패스워드를 좀 쉬운 패스워드 뭘로 할까? 예를 들어서 2006년 스프링 LA, 2016 S LA 그렇게 요거 패스워드를 바꾸세요. 그렇게 하고 공지해 주세요. Q&A에. 오케이. 그렇게 then you will not forget the password. So you can use this to generate your homeworks. You just practice there, and leave your names in the title of those practice, and then you use those solutions when you submit your solution in Q&A. That will help. Now, chapter 1. You know what's the definition of vectors and this scalar, the difference of vectors and scalar, and you have learned those. And vector is a concept which has not only the quantity, also it has the direction. So this is a kind of object with the magnitude and the direction. And you know vector addition and scalar multiplication. And you have learned the parallelogram laws. And also all the detailed lecture was saved in the YouTube already, so you can go through it. The scalar multiple and definition of vector in R2 and the equivalence of two vectors and how to figure out the given vectors are equivalent or not. And this is the kind of key. Then you can add or subtract using this code. And this is a vector addition and scalar multiplication. And the important thing here, these are things that you already know. But these concepts in R2 can be easily generalized to the vectors in R3 and R4 in Rn as well. This is what we are trying to show you in here. So in R2, we can add or subtract and do have a scalar multiplication. But also, the same thing can be done in R3 vector additions and vector. So you R2, R3, you can have a vector addition and scalar multiplication, and zero vectors and negative vectors are defined. And the same thing can be done in Rn. We can define the vector addition in Rn. We can define the scalar multiplication in the vectors in Rn in the same manner. And this is what. Two vectors are given in Rn. Vector addition and scalar multiplication are done in the similar way. And the codes are given here. And these are the properties of vectors on vector addition and scalar multiplication. And this is a property of zero vectors and negative vectors that you already know. This is a new concept for you. This linear combination of n vectors. Okay. If you have the k vectors in Rn, then this is called a linear combination of these k vectors. Let it be x. Then x is a linear combination of vi's. If you have three vectors, we can check the linear combination of these vectors can be found. And those computations can be done by this code. And this is a definition of vector norm, or magnitude or length. We call it a norm officially. And the x minus, the norm of x minus y is called the distance between 2 points, two vectors. Distance between 2 points or two vectors, like this. And it can be found in this way by the definition, and also can be computed by hand, so you can check they are same. 3 square root 2 and square root 50. And this is a definition of dot product, inner product. If you have two vectors in Rn, then x1 times y1 plus x2 times xy2 plus dot 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 plus xn times yn. This is called the dot product or Euclidean inner product of these two vectors. Okay? And this can be computed in this way. It can be easily checked with this. Inner product of these inner product of x and y is -1, like what you did in here. This can be done for the small size vectors by hand easily. But if you have a large size and very complicated form, then this code will be very useful. Same property holds for the vectors in Rn. And Cauchy-Schwarz inequalities. Yeah, I will give you a detailed and best way to prove these inequalities in later. But now you recall these Cauchy-Schwarz inequalities. With those inequalities, we can define the angle between two vectors, and we can define the orthogonality. Orthogonality, when this inner product of two vectors are 0, then we call x is orthogonal to y. Orthogonal. And unit vector, if the length of the norm of the vector is equal to 1. And inner product can be found in this way. And the triangle inequality can be derived from the Cauchy-Schwarz inequalities. And you can find the norms and the distance, and you can check the triangle inequalities and Cauchy-Schwarz inequality hold for arbitrary vectors in Rn. And unit vectors of this form is called standard unit vectors. 1, 0, 0, 0, 0, 1, 0, 0, 0, all zeros except the last one, 1, which is called the standard vectors. Then, with these standard vectors, the arbitrary vector x can be written as a linear combination of those standard unit vectors. This gives us this. The vectors here can be written as a linear, vectors in R2 can be represented as a linear combination of these two unit vectors, and vectors in R3 can be represented as a linear combination of these three vectors, I, j, and k, which is unit vectors, standard unit vectors. With this, in chapter section 3, the vector equations, we will learn how the planes and the lines can be represented with those vectors using the inner product concept. This is the new things. Before, those are the previews. Any questions for the review of the first two sections in chapter 1? Then, yeah, you have homeworks, and I expect you to go through the chapter 1 and the first two sections in chapter 2 before you come to class, and make any questions that you found while you are reading the first two chapters, which is quite easy to go through. Then it will be all answered and cleared during the next week. Then we'll continue the next chapter. Any questions? Okay, there are homeworks. These are the kind of homeworks that you're gonna start, probably from the next week, not this week. And this is very important. Yeah, this is all the solutions of this book that you can find. Yeah, you will Not many books has all the solutions. As you hear from the chapter 1, section 1, 2, 3, and here are all the solutions that you can use it. Okay. For example, in here, what you can do. For example, this is a problem 10 in chapter 1. Then you will see the scalar projection and the vector projection of y onto x can be found in this way from the definition. And this can be practiced in here like this. Okay? And if you make your own problems, then you will have the different answers like this. Then you can use this to make your solution for your problems. Okay? So just go through it as I mentioned. Just to try to practice. Yeah, but the first homework is just the introduction of yourself. And the next homeworks will be given from the second and from third weeks. So you just go through from the beginning. If you have any other questions, then we can close up the first class. Any questions?